Next in your note packet, you'll see a little review of 7.1 to 7.3. Looks like that. I'll show it again. It looks like this. I just have it kind of blown up on some bigger slides here for us to work with. So let's go take a look. This won't be a very long video. So first question is, what is anything to the 0 power? And you better know that by now that that's 1. However, again, we've got to be careful of the two different types of problems you're going to see. As long as it's all in parentheses, anything to the 0 power. However, if I put that negative outside the parentheses, remember that means -1 times. And so really what I've got to do is take all of this to the 0 power and make it a 1, but I had that negative out front. So be really careful how you use that rule. Again, these rules are easy, but there's lots of room for doing things that look good, and they feel good, and they feel right, but we have to make sure we're following the rules. So again, be really careful with the parentheses, and I just explained that we got to be really careful whether the parentheses are like this or whether the parentheses are like this, because one of them is 1 and the other is the opposite, or -1 times 1. On the next page, what we've got going here, what does a negative exponent actually mean? What it actually means is division. A positive exponent means to keep multiplying and multiplying and multiplying, whereas a negative exponent means to keep dividing and dividing and dividing. And the effect that it has is, if the exponent, let's flip and see what I got here. It sends what is being raised to the, and that should say negative power, to the negative, to the other level. What do I mean by that? Well, here's what I mean. If it's x to the -4th, I divide by x 4 times. If that negative was on the bottom, the end result is it brings it up to the top as x to the 4th. And this one might be confusing to you, but let me tie it into something from your middle school days that'll make that readily apparent. Remember, right here, ignoring the top, on the bottom, x to the -4th is 1 over x to the 4th. And we just said that this negative exponent means to divide by x 4 times. Well, I also had this 1 up here on the top. And you should have learned that division, right here, is the same as multiplying by the reciprocal. So we flip that over, and you'll notice the end result is it sent that negative up to the top as a positive. And again, always, we're going to be really careful with where the parentheses are. -2x to the -4th is -2 to the 1st, which is just -2, divide by x, or send to the other level 4 times. Very different from -2x to the let's even do it like this. Notice if I were just to read them, one of them is -2x to the -4th. The other one is -2x to the -4th. They sound very similar, but watch the differences. Still, this negative is out front. It's really a -1. It goes in my answer. This entire thing in parentheses is to the -4th. So the entire chunk goes down to be raised to the +4, but it's the whole thing, not just the x. Those parentheses matter in this problem. So I've got 1 over, and if I wanted to do I think I'm just going to leave it like that until we get to another section. Another section will tell us how to clean that up a little bit more. Now, how about if I had put it in parentheses like this? Then what does that mean? That means this whole chunk is to the -4th power, which means that whole chunk gets sent down to be raised to the 4th. Notice there's no negative hanging out front on this one because it was in the parentheses. So very tricky. Scientific notation, what does it look like? It looks like some number times 10 to an exponent. Remember, this number has to be between 1 and 10, but not 10. And this exponent must be an integer. Some examples, if I were to write 24,500,000 in scientification, I would get, again, 1, 2, 3, 4, 5, 6, 7 I went, right? 7. I'd have 2.45 times 10 to the 7th. If I were 0.00032, I'd go 1, 2, 3, 4. I'd have 3.2 times 10 to that negative 4. It's a very small number. By moving this decimal to the right, I'm technically multiplying. So to keep that in balance, I need to divide. I don't know how you like to think about that. I just like to say if it's big, I get a positive exponent. If it's a small number, I get a negative exponent. When we multiply expressions that have the same bases, what do? We simply add, and I should even be more specific than using a pronoun here. Well, you add your exponents, although I did say what do we do with the exponents, so I guess I got that covered. Some examples of that, at its very base form, something like that, just be x to the 7th. When I have some coefficients in here, and maybe some negative exponents, remember these out fronters I do out front, 2 times 5 is 10, x squared times x to the negative 3rd as a common base of x. I add those exponents and get a negative 1. I use my negative exponent property that says whatever's being raised to that power, in this case just the x, gets sent down or we divide by it. So there's that one. And we are moving right along. That's the end of our review actually. So the next video will be on section 7.4.